times faster at 1 million tokens. Yep, that's the kind of number that makes AI Twitter completely lose its mind.
Voicegear times faster than Mark. Or just
That's exactly the question. SubQ finally got a third-party benchmark report. And today, we are not here to cheer. We are here to dissect it. SubQ's original pitch sounded almost too good. A huge context window, lower cost, faster long context processing, and Zundamon coding performance.
That sounds like general AI can capture into dissect.
Exactly. And the claim wasn't just a model is a little better. Here's the thing. The claim went much deeper. Maybe the Transformer's quadratic attention bottleneck can finally be broken in production. In standard dense attention, every token compares with every other token. So if you double the context, the attention will grow roughly 4 times. At million token scale, that gets brutal.
Don't compare
Right? Their approach is called subquadratic sparse attention, or SSA. It tries to route attention only to the token relationships that actually matter. Now, Appen has published an independent benchmark evaluation of subquadratic's latest model in the SSA kernel. Great distinction. Appen says subquadratic engaged them for the evaluation. But the benchmark team only had API access. No weights, no training data, no fine-tuning configs, no ground truth labels. For the spin-defl OP analysis, they reviewed the key algorithm code and ran side-by-side tests. Yep, but weaker than fully open public code, public logs, and repeated tests by multiple independent labs. The strongest part of the report is efficiency. At 1 million tokens, Appen measured SSA at about 381 milliseconds. Flash attention took over 21 seconds in the same setup. That's where the 56.2 times speedup comes from.
It
Is? But it actually makes sense if the architecture really does change the scaling curve. Dense attention is punished harder as context grows. SSA benefits more exactly where the context gets enormous. But, and this part matters, don't say SubQ is 56 times faster than Claude. Say it like this. Appen measured SubQ's SSA input processing path as 56.2 times faster than flash attention to dense attention at 1 million OP. Under this specific setup, less sketchy, but way more accurate. Latency alone can be tricky. High width, kernels, batching, implementation details. All of that can distort results. So the FLOP numbers really matter.
Undercan says the slope of catching was 62.8 times at 1 million tokens.
And they validated the FLOP estimates using Torch. Cloudflare, the measured FLOPS matched predictions within a few percent. Basically, this is the strongest SubQ might actually be real moment in the whole report. It doesn't prove every product claim, but it strongly supports the core technical claim. Essays doing dramatically less attention, work at long context.
Exactly.
Sparse attention has a real danger. If the model skips the wrong token, it can miss the entire answer. On RULER 128K tokens, SubQ scored 95.6% overall on QA and word extraction. It got perfect scores on several of the single needle tasks.
Good
catch! That's not a disaster. Because multi-Kaylee retrieval to be hard, but it's the first reminder. Long context ability isn't a magic spell. Complexity still hurts. So RULER supports the idea that SubQ can use long context well. It does not prove that every messy real-world document workflow is solved. The most impressive quality result is M. Our CR at 1 million tokens. Appen tested the hardest state, middle tier, and SubQ averaged ITX is 0.2%.
What size? 또 more meaningful. 그래서 또 미리도 만에 예스택 캐스트. 더즈기대.
It really is. MRCR asks the model to retrieve multiple pieces of evidence, not just find one planted sentence. That's much closer to real long context work. But again, it's still 100 samples. Strong evidence, not final proof. Then comes SWE bench verified. SubQ scored 80, 1.8% with extended thinking enabled. Very high. It puts SubQ right next to frontier coding models. But here's the thing. It does not crown SubQ as the coding king. SubQuadratic's own comparison unlists Opus for points even at 87.6%, above SubQ's 81.8.
主が目をしといですな。just to the store is stored. Cannot test.
Correct? The real story is that a new architecture is already competitive on a real software engineering benchmark, while possibly being far cheaper for long context workloads. Okay, so here is what the report does support. 1. SSA's long context attention efficiency looks seriously validated. 2. SubQ performs strongly on 128 Cayenne 1M retrieval benchmarks. 3. SWE bench performance is frontier adjacent. And here is what it does not yet prove. It does not prove SubQ beats Opus for 0.7 or GPT 5.5 overall. It does not prove the public product performs the same under real user load. It does not publish all per-run logs and full methodology openly. It does not replace broad general benchmarks, safety evaluations, or live user testing. And it does not prove the 12 million Oken research claim has the same quality as the validated 1 million Oken results.
シャムコナットはまた私構成する使うかい。
Exactly! This isn't vaporware anymore. But it's also not checkmate. The Appen report changes the conversation. Before, SubQ was a spectacular claim. Now it's a spectacular claim with serious third-party evidence behind it.
とともるステラスと試験兵がきっぱんたい。
Yep. Public access, reproducible evaluation, real developer workloads, more benchmarks, more independent labs. If all of those hold up, SubQ could genuinely change the economics of long context AI.
アンデステイドンキス。
Then, it becomes another reminder that AI benchmarks can make a model look like the future, right up until users discover the footnotes. SubQ hasn't won the AI race, but for the first time, the race might just have a new kind of ending.